All substances consist of small particles held together by bonds. In this 3-minute lesson we look at what those bonds are and how they form. A chemical bond is the attractive electrostatic force formed between two opposingly charged particles.
Let's look at what happens between two different atoms, a sodium atom and a chlorine atom. All atoms have a nucleus containing positively charged protons. Sodium nuclei contain 11 protons and have a nuclear charge of 11 plus. Chlorine atoms have 17 protons and therefore a nuclear charge of 17 plus. The nuclear charge is shielded by negatively charged electrons surrounding the nucleus. All atoms have the same number of electrons as protons, which results with atoms having a zero net charge. The outer electrons in atoms located on the left and centre of the periodic table are weakly held and are easily lost. Losing electrons decreases the electron shielding, producing an overall net positive charge. Atoms located on the right side of the periodic table have a strong hold on their outer electrons. Free electrons approaching these atoms can be gained, thus producing a net negative charge. Particles with an overall net charge are called ions. The attractive electrostatic force formed between two opposingly charged ions is called an ionic bond. What happens when two atoms from elements located on the right side of the periodic table bond? Let's take two chlorine atoms. The outer electrons in these atoms are strongly held. As the atoms approach, the nuclear charge in one atom may induce an electrostatic force on the unpaired electron in the other atom. This results in a pair of outer electrons being simultaneously attracted to both nuclei. This pair of electrons is effectively shared by both atoms. This is called a covalent bond. When atoms located on the left and centre of the periodic table combine, the outer electrons are easily lost, forming a cloud of free electrons. These are called delocalized electrons. The resulting positive ions form a rigid structure held together by the attractive electrostatic forces between the positive ions and surrounding delocalized electrons. These forces tend to be very strong. The mobility of the electrons ensures characteristic properties. For example, the electrons can transfer heat and electrical energy. These materials are good thermal and electrical conductors.
All three types of bonding described in this lesson, ionic, covalent and metallic, are examples of strong bonds. Typically, the breaking and forming of these types of bonds involves large enthalpy change and are associated with chemical changes. The next 3-minute lesson introduces other weaker interactions between particles, intermolecular forces.